introduction hydraulic jump. A hydraulic jump occurs when a high velocity fluid flow abruptly transitions to a lower velocity flow. The purpose of this hydraulic jump experiment is to look into and evaluate the behavior and characteristics of a hydraulic lift. In this experiment, a controlled hydraulic system will be built up to produce hydraulic jumps in a lab environment. Before and after the hydraulic jump, we will measure and examine a number of factors including water flow rate, water depth, and velocity.
The problem statement of hydraulic jump. We will require to use the rectangular flue which is installed in the hydraulic laboratory. Additionally, we will expect to install the sluice gate in the rectangular flue at the point that the laboratory assistant or lecturer will specify. Then, we were given the task of identifying the variation between the experiment upstream and downstream depth of flow. The values of H, H1 and H2 are calculated using figure 1. The specific energy located upstream and downstream as well as the power loss caused by the leak were computed using the measured depth. Additionally, it was assessed how much power and head loss the hydraulic jump caused.
The objectives of this experiment are, first, to investigate the characteristic of hydraulic jump produced when water flows beneath and under shock wear. Second, to observe the flow patterns obtained. Third, to analyze the hydraulic jump characteristic under different conditions. Fourth, to understand the role of hydraulic jump in energy dissipation.
The procedure of hydraulic jump. First, we measure the channel width and close the reservoir outlets. Then, start the pump and regulate the discharge valve in order to reach the required flow rate.
Adjust the sluice gate in order to obtain a free flow. Measure the depth upstream and downstream of the jump, H1 and H2 respectively. Note down the values.
After that, measure the depth of H at before sluice gate.
6. Determine the discharge in the channel using the flow meter. Apply the necessary conversion to change the reading to the standard units for discharge in meter cube per second, and calculate the upstream and downstream velocities V1 and V2 in meter per second respectively. 12. Repeat step 4 to 10 to get 3 different values of flow rate by using different rectangular plates.
Discussion. The hydraulic jump experiment provided valuable insight into the behavior and characteristic of hydraulic jumps. The result obtained from the experiment contribute to the understanding of fluid dynamics and have practical implications for hydraulic engineering projects. The experiment proved that abrupt increase in water depth and decrease in velocity are what cause hydraulic leaps. Turbulence is produced and kinetic energy is transformed into potential energy during the jump. The phenomena can be verified by the observed flow transition, which enable us to thoroughly examine its mechanics. The experiment findings have implications for hydraulic engineering projects on a practical level. Hydraulic jumps are frequently seen in water treatment facilities, river engineering and dam spillways. It is possible to enhance the performance and security of such structure by comprehending their behavior and making design improvements. The results of the experiment can be directly transferred to real-world situations, making hydraulic system more reliable and efficient. Conclusion. In conclusion, the hydraulic jump experiment provided insight into the characteristics and behaviors of hydraulic jumps. By taking careful measurement and analyzing the result, we were able to gain a better understanding of the flow patterns and changes related to hydraulic jumps. The experiment demonstrates that hydraulic jumps occur when a high velocity fluid flow abruptly switches to a lower velocity fluid flow, and the changes in water depth, velocity and other relevant parameters that were observed before and after the hydraulic jump provided quantitative data to characterize the phenomenon. We were able to investigate the sensitivity of hydraulic jumps to various situations by altering experimental factors such as flow rate, channel slope or barrier shape. As a result, we were able to pinpoint the variables that affect the development and behavior of hydraulic jumps, which has important implications for design and improvement of hydraulic structure.